video, we're discussing the inference procedure to compare two population means against one another. In the past, we did things like this. We compared a population mean against a constant value, right? So we said something like the mean test scores for men on the first exam in my class is less than or equal to 72. So I could make a statement before like that. I could test that or form a confidence interval to try to test that. And that's what we did basically in the previous sections of confidence interval and hypothesis testing. Now what we want to do is to expand this idea to compare two population means. For example, I might want to say that the mean for men is less than or equal to the mean for women. I can do something like that now in this section. So compare two population means. That's the new idea. All right. You can also make a statement that right now we're just making a relationship. Males are either less than or equal to women on average, right? I could also do something like this. I could, move this guy over and say that the mean for men minus, right? If I move this over, it becomes negative, so that's why I put the minus. The mean for women is less than or equal to 0. So I have a statement that's equivalent here to the statement above. But you can imagine if I wanted to specify a specific difference, right? I could actually say, well, hey, maybe that difference is less than or equal to 10, right? So the difference between men and women, the value separating their two scores is less than or equal to 10. I could make an inference about that and test that if I wanted to. So we have a lot of flexibility here. But basically the whole idea is we're comparing two population means as opposed to just looking at one population mean and trying to estimate it or compare it to a value. So what we want to talk about first is the confidence interval procedure to do this. And we're going to leave out some of the theory because some of the theory is a little technical. I might introduce a video after this which will explain some of the theory, but for now let's just get the general idea and see how it's similar to what we did in the past and to see how it's different at the same time. So first thing we want to do is look at the first step of confidence intervals because we're going to be talking about confidence intervals in this first video. The first step you want to always do is to get the data from the problem, right? So we had a data step. And in that data step in the past, we used to get a sample size, right? And then we would have a sample mean, and we used to have a standard deviation and a confidence level. And from the confidence level, we would have alpha, right? So we had this in the past in our problems. The only difference is now we're going to be working with two sample sets of data because we're going to have two independent populations. For example, the population of males, population of females. We're going to draw a sample from each of those populations. And so we'll actually have a sample size for the first group, but also a sample size for the second group that we surveyed, right? We'll have an X bar, or sample mean for that first group, but likewise we'll have one for the second group as well, and then a standard deviation for the first, a standard deviation for the second. Of course, confidence level and alpha, we just have one of each of those. So that's our data step, so we have an extra set of information in this new type of problem. All right, the next thing we used to do, if you remember, was to get table value or critical z value or t value depending on the sample sizes involved in the problem. So in step 2 here we're going to be doing z alpha divided by 2 assuming that these sample sizes are large enough to justify that, or if you're in another course where they use a more formal approach you would say if you know the population standard deviations and you can assume normality for the variables then you would use z alpha divided by 2. But either way we'll have this table value. And actually the way to get it is exactly the same as we got it before. So if you knew how to do this in your previous section of confidence intervals, you still know how to do that, no change. All right, step 3 then of the process is to get the margin of error. Now in the past, our margin of error formula was basically structured this way. We'd have the table value, z alpha divided by 2, and it would multiply by the standard error. That's going to change a little bit. We still have the same concept, table value times the standard error, but the standard error is a little more complicated. It's actually going to be this formula, sigma squared for the first population over the sample size used from the first population plus sigma squared for the second population over the sample size used for the second population. And again, you can use the S values as a substitute for those quantities, assuming your sample size is sufficiently large, or assuming that you're using the assumption that you have normality and the population values are actually known. So it depends which class you're in. If you're in my class, all you need to do to be able to use these S values as replacements for these population values is to assume these sample sizes are both over 30. Okay, by the way, that's your formula for the margin of error. And then finally, step 4 is to take your point estimator and subtract off your error. Now, if you remember before, we would have something like X bar minus the error, right? And then we'd have comma, x bar plus the error. Well, that really hasn't changed all that much, except for we have a new point estimator. It's going to be x bar 1 minus x bar 2, and then x bar 1 minus x bar 2 over on this side. So we actually have a new point estimator. It's no longer just x bar minus the error. It's x bar 1 minus x bar 2. And you may say, well, why is that your point estimator? Well, remember, we're trying to talk about the difference between two means, right? So the estimator of that is x bar 1 minus x bar 2. Because what we're trying to estimate is essentially what? The mean for the first population minus the mean for the second population. So that's the quantity we'd like to know, and the best point estimator for that turns out to be x bar 1 minus x bar 2. Okay, so those are your 4 steps, and you can see they're not that far away from what we did in the past. Essentially, with these formulas and with the information in the problem, you should be able to do the work that you need to do. We have lots of practice videos for you to look at examples, so you can watch the practice videos to see how this is actually applied. And then the next video, we're going to talk about some technical details just to see why this is, in fact, the standard error for x bar 1 minus x bar 2. We'll also talk about what property this has that makes it a good estimator for this quantity. Okay, so that's it for this video, and watch the next video if you're interested in those technical